our learnings and goals.
Okay, so who are we? We are TechnoSharks, a team of ambitious innovators united by our passion for STEM, AI, and machine learning. We don't just build robots, we engineer solutions, inspire communities, and push the boundaries of technology. Our mission is to empower the future through innovative robotics and STEM education. Join us as we compete, learn, and inspire the next generation of engineers. Okay, these are our team members. My name is Radhika, and I am the team captain. I specialize in electrical and outreach.
My name is Zomkan, and I specialize in software.
My name is Prisha. I specialize in software and outreach, and I'm part of the drive team.
My name is Sahasra. I specialize in mechanical and I'm part of the pit crew.
My name is Veer, and I'm in the mechanical team, and I'm part of it.
My name is Devansh. I specialize in mechanical, and I'm part of the drive team.
My name is Soham. I specialize in electrical and documentation, and I'm also part of the drive team.
Hi, I'm Ara, and I'm the software lead and part of the pit crew.
And Shreyans specializes in CAD.
My name is Rishin. I specialize in computer vision and I'm part of the pit crew.
Hello, my name is Tanay and I specialize in mechanical and marketing, and I'm also part of pit crew.
My name is Rishi, and I specialize in CAD.
Alright, so here's more about our team. So our history is that we were a rookie, or that we are a rookie team right now for FTC. And before this, some of our team members were in an FLL team that went to states. So our accomplishments so far is that our entire team learned Java, and we are using it in our robot. And then all of us know a bit of electrical and some of the electrical basics, and all of us have done a bit of mechanical research. So our team structure is we each have separate roles, like captain, co-captain, mechanical lead, or electrical lead, marketing lead, and all that.
Okay, so now we're talking about the overview of FTC.
So, what is FTC? FTC is a competition for middle and high schoolers where every year you build, design, program, and test your robot to tackle a challenge of that season. How it works. Every game you get an alliance to go with. Every alliance is made up of 2 teams, and they compete to try to complete a challenge for that season. The programming works like this. There's an auto and a teleop period. Auto periods are pre-programmed robot movements, and teleops are user-programmed and used. You also have an engineering portfolio that you have to present to judges that show what you've learned over the season and postseason. What you get from this. In FTC, you are exposed to collaboration, teamwork, leadership, and like right now, outreaching to hundreds, maybe thousands of people.
So this is the season theme for 2025 to 2026. It's called Decode.
Welcome to the first Tech Challenge 2025-2026 season game, Decode, presented by RTX. Decode is played by 4 randomly selected teams, 2 per alliance. Your opponent for one match may be your partner for another. Robots must be built to meet the specifications in the competition manual and fit within an 18-inch sizing cube. Robots and their extension must remain within the 18-inch sizing cube until the end game. The game is played on a 12-foot square playing field with a foam tile floor and 1-foot-high walls. On the playing field is a red alliance goal and a blue alliance goal. At the exit of each goal is the classifier ramp. and score in their goal, open the gate to clear the classifier, and collect artifacts, ranking point. The alliance that earns the most points overall wins the match and will earn 3 ranking points. This has been a summary of this season's game, Decode, presented by RTX. For complete rules, please read the competition manual. And always remember to demonstrate the first ethos of gracious professionalism. Good luck, teams, and have a great season.
Okay, so now we'll talk about the FTC deep dive. So, as we've mentioned before, the game consists of 2 periods, the autonomous and tell-up periods, where the robot must move by itself, and it also must be controlled by, of course, Unity software. So, as a coder, it's my job to program the robots so that it can move, shoot, and score points throughout the game. Okay, so another critical part of FTC is outreach. This is something we're doing right now. It's where you talk to big groups of people like industries or just organizations, and you do this for fundraising or inspiring future STEM innovators.
In CAD design, you create parts and tools for the robot to be built in the best fit way for the benefit of the team, and after designing, objects are often 3D printed for the robot.
Our team must implement mechanical skills to build, fix, and iterate prototypes of robots for gameplay. Okay, so now we're going to be talking about our engineering design process.
So what is the FTC design process? Well, the FTC design process is essentially a method that a lot of teams use to build their robot. And it makes everything more efficient and effective and more time-bound. And this can also help students with gaining exposure to the real world. And there's 6 overall steps. First, research. We have a game challenge in every season, and really cultivating a solution to the game challenge is really important for our teams to thrive. Next, we have concept, parts list, our manufacturing process, and then now we have the build part. And now we're actually building our robot. We're buying parts and we're assembling things. And what this does is that we're also just really keeping everything organized so that the documentation team can document all of this. And finally, we have testing. And what we're doing for testing is that we're gathering data and testing our robot for how effective it can perform. And finally, we're improving. We have to improve because there's endless possibilities for a robot. And what we can do is that we just go through the entire process again and we test different parts so that we're actually ready for game day.
Okay, so now we're going to be talking about tools and techniques we use.
For CAD, we design parts and tools for our robot to customize it to our needs for the gameplay, and we use Onshape as the app for CAD.
FTC robots are programmed using Java, and we use an IDE called Android Studio. This is where we code the robot for motors, sensors, and code our autonomous routine.
For sensors and electronics, we use sensors like encoders, gyros, and cameras, which can help the robot move around, navigate, aim, and make decisions automatically. It's like the robot has its own brain, eyes, and ears, which gives us real-time feedback and makes it act smarter.
Engineering notebook. This is where we document our processes, design, and code. This is very important for winning various FTC awards.
Okay, so now we'll be talking about our learnings and goals so far for the season.
So what we really want to do is we want to build and code real robots and learn science, technology, engineering, and mathematics through hands-on activities. Teamwork is a critical part of FTC, and learning how to work with a large amount of people and listening to their thoughts and ideas is really important.
So I'll be talking about problem solving. So I mean, as a team, you guys probably also face challenges all the time. So that's why problem solving is a key to have one in FTC, skill to have one in FTC. As a team, we have bumped into numerous problems along the way, so knowing how to overcome them is essential. The best way we overcome these problems is that we listen to everyone's ideas. Listening to everyone's ideas allows us to solve the problem, and also, because of that, good communication is important.
So another important skill that we learned and improved is our confidence and leadership skills. It's important to be confident when you present to the judges, so you sound like you know what you're talking about. And we also develop communication and leadership skills, which helps us present to other people and communicate with our team.
Okay, so like I talked about before, outreach is another critical part of FTC. Examples of what we've done so far, our team has taught Java to a group of students. We've helped FLL teams understand how FLL works, and we've also helped all around like a lot of people.
Mechanical. For mechanical, we have to make sure that our robot is versatile, strong, and durable. For this, we have to brainstorm different ideas. We also have to make sure that we have a good intake and launcher.
For robot gameplay, our team strives to get a large amount of points during gameplay, and we continue to iterate our game strategies and our game plan in order to do that.
For software, we aim to code the robot to make the driving during teleop easy and effective. And for the autonomous period, we aim to make the shooting part very easy without the human guide.
Okay, so now we'll be showing you our robot demonstration.
Nice.
Okay, so we have an intake mechanism at the start. It allows our robot to intake balls. And then we have these wheels that shoot out the balls into our align schools. And now, as you can see, our robot's collecting that ball using the spinning wheels.
The intake mechanism. So as you can see, it's storing the balls inside of it before we shoot.
And now it just shot the ball to our partner.
So there are starter kits for these robots, but we started off with a starter kit and then we iterated it and added our own ideas. So we used the engineering design process to make this robot. So we came across many challenges before we came to our final solution that we have right now. And we are also currently making another one too.
Okay, so a lot of you guys are doing FLL. When you outgrow FLL, FTC is a really good
potential thing for you to do because it allows you to combine outreach, robotics, and STEM skills to a whole new level. Okay, so if you have any questions, you can come to us after this event about FTC, right?
Okay, that's the end of our presentation. Thank you guys so much for being an amazing